In the last video, you initialized a new Git repository for the web server project. You also added a couple of commits, and now we can take those commits and send them off to these third-party services we want to use, GitHub and Heroku, so they can access our latest code. That's how GitHub will be able to host our project, and how Heroku will be able to deploy the latest version of our application. Now the question is, how do we transfer the code between our machine and the other third-party services servers in a secure way? And the answer is to use SSH. SSH stands for Secure Shell, and it gives us a means of securely communicating with another machine. And in this video, we're going to set up what's known as an SSH key pair. This is a set of two files which we'll be using to facilitate this secure communication. Now, to actually generate these files, all we need to do is run some commands from the terminal. Then in the next two videos, we'll actually set things up with both GitHub and Heroku. Now, if you're on Mac or on Linux, you can stick with your standard terminal. If you are on Windows, you need to use the Git bash program. So remember when we first installed Git, I said that if you're on Windows, as you move through the installation process, you want to check that box that says install git bash. This is when we're actually going to use that program. The commands we're going to run are not available to you from the standard Windows command prompt. You need to use git bash to access them. Now, if you didn't install git bash when you installed Git, you can always grab the installer again, rerun it, adding the option to install git bash. Then you can continue on with the lesson. So once again, Windows users crack open git bash. Mac and Linux users, you can stick with your terminal right inside of Visual Studio Code. Now, the first thing we're going to do is see if we already have SSH keys on our machine. It's possible you have them from another project you were working on. The command we're going to run is ls. Now, ls allows us to list out the contents of a directory, and this is going to allow us to check for existing keys. So it's going to list out all of the files and folders inside of a given directory. We're going to be running this with the A flag. The A flag makes sure that even hidden files and folders show up. These would be ones that start with a dot, also known as dot files. And we'll also use the L flag. This is just going to make the format a bit easier for us to read. It's going to list everything out top to bottom instead of trying to use columns where we have things side to side. And the last thing we need to provide is the path to the folder of which we are trying to print its contents. Now for us, that is going to be the following. It is tilde/.ssh. So tilde is a shortcut for your user directory. Then we're looking for the .ssh folder. Now there's a chance you don't even have this folder, in which case the command's going to fail. That is okay. It's perfectly fine if you get an error, something along the lines of directory not found. In this case, when I run it, the folder does indeed exist, but there's nothing inside of it. I have dot, which represents the directory, and I have dot dot, which represents the parent directory. There are no files inside of the .ssh folder, which means that I don't have any SSH keys. Now, if you have a file called id_rsa and another called id_rsa.pub, that means you do already have a set of SSH keys, and you could choose to use those instead of creating new ones. There is no need to create new ones if you already have some in place. Now, if you are seeing what I'm seeing and you have no files or you don't even have the folder, it's time to run a couple other commands to create some SSH keys that we can use. The command we're going to use is ssh-keygen, which is going to allow us to generate this SSH key pair. The first argument of 3 we'll be providing is T, which stands for type. There are various protocols we can use. We'll be using the very popular and very secure RSA protocol. Now, RSA doesn't stand for anything in particular related to software development. It's actually just the last name initial for the 3 creators of the algorithm. So after RSA, we're going to specify B for bits. We want to specify how many bits for this key. We want enough to be secure. The most common value is 4096, so 4096 bits for the key. Last up, -C. Make sure it's capital and not lowercase. This is where we can provide a comment for the key, which you can think of as a label, and it's common to just use your email address inside of here, and that's what I'm going to do right here. Perfect. Now that we have this in place, we can go ahead and hit enter to run the command. This is going to bring us through a little wizard, which is going to ask us a few more questions. Enter file in which to save the key, and by default, you can see it storing it in that .ssh directory inside of my user profiles folder, and the file name is id_rsa. I do want to use that default, so I'll just hit enter to accept the default value shown in parentheses. Next up, enter a passphrase. We're not going to provide a passphrase, so we can hit enter to use the default passphrase, which is no passphrase. After that, we hit enter again to accept our passphrase, and then right here, the key has been created. Now, what we're going to do is run that same ls command. So I'm going to use the up arrow key twice, hit enter, run it, and now I can see I have two files. I have id_rsa and id_rsa.pub. The first one is a secret file, which we're going to keep on our machine and we're never going to share with anyone. The other is a public file, and this is something we're going to share with both GitHub and Heroku, so it can secure the communication between our machine and their servers. The last thing left to do is to make sure that our SSH key pair is actually used the next time we set up an SSH connection, which we will be doing in the next 2 videos. The first thing we need to do is make sure the program is running, and then after that, we're going to register our new private key file. So right here, all together, we're going to run the following command. It is eval. Now, if you are on Windows, you're going to leave the next character off. If you're on Mac or Linux, you add the quote in. After that, it is $, open and close parentheses. Then once again on Windows, nothing. On Mac and Linux, add that quote in. Then inside of the parentheses, the command, which would be SSH agent S to start that up. So all this command is going to do is it's going to try to start up SSH agent. If it's already running, it's going to simply tell us that by printing the process ID. If you're on Windows, you should have this command minus those 2 quotes. I'm going to go ahead and run it, and what do I get? I get agent PID 8743, which means that things are already running. After running this command, the last thing to do is to register the file. That's SSH-add. Now, if you're on a Mac, you have to use the $K flag. This is going to make sure that things get added correctly. If you're on Linux or Windows, you do not want to use that $K as it'll cause a problem. From here, we simply provide the path to that private key file. .pub is the public one. The other one is the private one. That is ~./.ssh/id_RSA. When we run that command, we can see the identity has been added. Now, when we try to facilitate an SSH communication, we'll be able to do it securely using our key pair. Now, at this point, we haven't actually used the key pair to do anything. In the next video, we're going to address that by getting our code pushed up to the GitHub servers. I'm excited to get to that. Let's go ahead and jump right in to the next video.